Hello and welcome to tonight's edition of Interactive Stargazing. My name is Ariel and I'll be your host for tonight. What we're doing here is we are giving you a live stream of exactly what we're looking at through our 14-inch plane wave telescope, 14-inch reflecting plane wave telescope. The program that we're using is our Cam software. So we have a little camera mounted on to the 14-inch, and we're going to be taking long exposures of various deep sky objects for you guys. So, if you've already been here, you know the sitch, and we'll just get it going then. So to start off, right here, the object that we're looking at, we're actually looking at 4 different objects. We are looking at the Leo Quartet. So this is 4 different galaxies in a single view. So right in the center, or I suppose the brightest galaxy in there is NGC 3190. So that is a spiral galaxy about 80 million light years away. Now, the neat thing about the Quartet is all 4 of these galaxies are pretty, they're gravitationally bound to each other. So the galaxy just to the left of the bright galaxy in the center is NGC 3187. So that's another little spiral galaxy. And just beneath those 2, it looks like a fuzzy star, but that's actually an elliptical galaxy. And elliptical galaxies don't have much star forming going on. What's going on is all of that gas that's used to make a bunch of stars has been used up. So it looks like a big ball of stars, a giant ball of stars. So that's why that object kind of in the right side, the one on the right, magic hand. Yeah, that one is an elliptical galaxy. We can just see between the other 2 in the center and the one on the right that these are 2 different types of galaxies visually. And up on the top, there's another little tiny guy, and that galaxy is, I believe, NGC 3185. So it's another spiral about 75 million light years away. So we are looking, tens of millions of light years into the past by looking at these objects. Now I see a question asking if Ursa Major will be visible tonight. So Ursa Major is the largest constellation in the night sky, and we are looking at a very, very, very small area of sky. So we'd be able to grab like a single star in the Ursa Major constellation, but we could jump over to a deep sky object in the Ursa Major constellation, and I see a request for one, which is M51. This is wonderful. I love M51. Like in the entire night sky, like M51's top 10, one of my top 10, maybe top 5 of my favorite objects to look at. So on the screen here, what we're doing is we are going to the object. So we're using the planewave software to have the telescope zoom on over to the object, and then we're using the Cam software to take a long exposure of the object that we're trying to grab. So we spoiled it. This guy right here is M51. We were so excited about it, we already took a picture of it. M51 is the Whirlpool Galaxy. So this guy is about 30 million light years away. And what we're seeing here is one of my favorite things to say, because it's like a real sciencey science term called galactic cannibalism. So that big galaxy on the top there, just looking at it, it looks bigger, it looks more massive than the smaller little dude on the bottom there. So the larger galaxy is eating the smaller galaxy. We can see the spiral arm to the far right. It's coming out of the center of the main galaxy, and it's kind of swooping in to the little galaxy on the bottom there. We can see, the 2 galaxy centers. So there's these 2 black holes keeping these galaxies together, and there's a ton of stars orbiting around those black holes, which is why the cores of the galaxies look so much brighter than the spiral arms. So in the spiral arms of that main galaxy on the top there, we see bright light, and then we see some darker streaks as well. So that's a bunch of star forming going on, and it's a super energetic, pretty young galaxy when we talk about the grand scheme of galactic ages. So still a couple billion years old, but it's a very active galaxy, and this collision is going to be pretty And it is looks pretty active right now. I see a request to see a spiral galaxy. So right here, this is actually a great example of a spiral galaxy. And we can jump to other ones as well in a little bit. Um, but yeah, Whirlpool, I just think is so cool and so pretty. And I also really quick wanted to let you guys know, I believe there are some controlled fires happening in Flagstaff right now. So for some reason, while we're taking a long exposure, it gets like yellow. Don't worry about it. It's just some smoke passing through. But I'm pretty sure most of the views that we get should be pretty all right. So actually, before this stream started, we had a couple requests. One of our buddies, it's their birthday. Happy birthday. And there was a request to see M95. So M95 is a barred spiral galaxy in the constellation Leo. So what that means is like the Whirlpool Galaxy, those, we can see the galaxy's core and the spiral arms are really neat. They're kind of, zooming around exactly just like that. A barred spiral galaxy, rather than being like a single, what looks like a hole, or not a hole, like a circle in the center there, it's more so like a line. So it's like a bar in the center of the spiral galaxy. So we're going to be taking a 20-second exposure. On the bottom of the screen there, we're able to see how far along we are in the exposure. And then we'll get the image in a second. I actually don't recall ever really looking at this guy before. Oh, neat. Yeah. So maybe we could zoom in a little bit. And you might be able to see what I mean, because there's the core of the galaxy, and then coming off of the edges, there's kind of lines coming out as well. And it's just another type of spiral galaxy. So it's the same sort of movement as a normal spiral galaxy, where it's just all spinning around, but instead of being a core and then the spiral arms coming directly out of the core, the spiral arms are coming out of the bars of the core. So I see a request for NGC 2281. I believe we should be able to grab this one. So he's setting right now. Right now, it's in the constellation of Auriga, the Charioteer. Even in the screen right now, we can kind of see it's heading towards the western sky. And, everything rises in the east and sets in the west. So he's setting right now, but we should still be able to grab him. I also see a question, is the deck structure officially open now? So the Open Deck Observatory, as we've been slowly reopening more and more after COVID. I mean, it's still a thing, but we're reopening safely. We are doing reservation-based viewing at the Open Deck Observatory. So we have an expanding universe tour that you're able to make reservations for, where you can get tours of our Pluto Discovery Telescope, the Clark Telescope Dome, and look through our Open Deck Observatory scopes and constellation tour. And we also have our dark sky tours, where if you just want to get some viewing through the telescopes, it's viewing through the Godot telescopes as well as constellation tours. And we also are doing our private programs in the Dyer telescope, which is a 24-inch reflector. That's actually up past the Clark. It's not on the plaza. And we are doing our Clark viewing again. I'm really excited about that one. Yeah, you're able to get more information or sign up for the reservations at lowell.edu/visit. So right here, we are looking at NGC 2281. So again, this is an open cluster in the constellation Auriga, the Charioteer. So open clusters are kind of like they're just nice spread out areas of stars. It's a denser area of stars in the sky. So all of these stars are younger, and they came from a nebula. Most of these stars in the field of view that we're seeing right now came from the same giant molecular cloud of gas and dust. So all these little stars here are like little family members, and over time they're going to be drifting apart from each other because of a weak gravitational pull. So All right, I see another request, or I see a request for the Cigar Galaxy, or M82. Um, this guy, um, he's been one of my favorites to view uh, through our plane wave telescopes. I like viewing him through our 32-inch star structure telescope at the Open Deck Observatory, and then looking at him through our Malincam software, because you can see, it's neat to see something with your eyeball through a telescope and then cheat with our Malincam software and get real up close and personal. So while we were taking the exposure, the telescope was moving. So you may notice the stars look like they're moving, or like we're going light speed. It's just we started taking the image while the telescope was moving. No UFOs yet, but right in the center there, that is M82, or the Cigar Galaxy. So like the Whirlpool Galaxy, we were looking at that spiral like face on, so we're able to see the core and the arms. With this guy, we're looking more edge on. So we're still kind of able to see, like in the center, it's pretty bright. And as the edges kind of taper off, that's, as we're getting further and further away from the core, there's not gonna be as many stars or as much stuff. And this is a pretty active galaxy as well, because we can see what looks like sort of clouds in the front there is more gas, primarily hydrogen gas, that's helping form a bunch of baby stars in the galaxy. So I see a request to see any irregular or elliptical galaxies. So I actually would love to look at the ringtail galaxy for this one. So this one looks kind of funky. It looks very interesting. It's actually kind of the next step after it's a galaxy also colliding. It's more galactic cannibalisms, galaxy collisions. The ringtail galaxy, or the antenna galaxies, or NGC 4038, goes by many names. These are galaxies colliding in the constellation of Corvus the Crow. So it doesn't have a perfect galaxy spiral shape, as you'll see in a second here. They look funky, like an antenna, or I suppose a ringtail, whatever that means. I guess it looks like that. But we can see, or this guy, I mean, I suppose we can't quite see that it's 55 million light years away, but I'm going to tell you that it's 55 million light years away, because it is. And there are two galaxy centers that we can see, like the brightest kind of portions in the galaxies there. Yeah, thank you, Magic Hand. Wonderful. So we can see that these galaxies are interacting with each other. The spiral arms are no longer super spirally. They just kind of look like strands being flung out. And just above the galaxy on the top there, it looks like smoke or fuzz. And those are just like individual stars and like gas that's being flung out because of how powerful these gravitational forces are. So it looks like a smudge, or it looks like it's nothing, but it's like cool. I think galaxy collision is really neat. I think it's really, really cool. I see a request to see a planet. So Mars is in the sky. It's setting right now, but we should still be able to grab him, so we can see our whole night sky on that screen right there. So Mars will kind of look like a little orange dot. Zoom, we're zooming on over to him. Mars will look like an orange dot in the sky. So the reason why it kind of looks like a star right now, the reason why we have these kind of twinkles coming off, is because of how the telescope is built. So we have the large primary mirror at the base of the scope and a smaller secondary mirror kind of at the top of the scope. And the secondary mirror, it's not just, levitating, it's being kind of held in by prongs. So the four things that we're seeing is the light reflecting off of the prongs there. So yeah, as we lower the exposure, we're able to see that it's just a little guy. He's a little guy. I think it's like 130 million miles away right now. Mars is at a further approach to Earth right now. As we lessen exposure, it does look orange. That is in fact Mars, I promise. And the reason why it looks kind of like fuzzy right now is we are on video mode. So we're taking, a fraction of a second of exposure, like the video. And we get like turbulence, upper atmospheric turbulence. So just wind in the atmosphere will make it look like it's moving around and bumping around. So Mars is a neat little dude. He is actually the reason why the observatory was founded. Lowell was founded back in 1894, specifically to map and study Mars and to find the aliens. So we were almost there. Now I see a request from Steve for M106. So Messier 106 is a spiral galaxy in Canes Venatici. Spiral galaxies, for the most part, they have the same sort of shape, that spiral shape where you have the core and the arms kind of coming out, but they can, be kind of oriented differently. So they may look different depending on which ones we're looking at. So we're taking a 17-second exposure. I can't recall exactly what this guy looks like, so I'm just excited as you are, just as excited as you are here. Oh, he's a neat guy. Cool. So he's kind of like almost kind of face on and a little sideways. Neat. Yeah. So we're able to see, that core. We see really dense gaseous regions kind of right in front of the core. Yeah, right there. And then those stars are kind of spun around that core there, which is why there's those brighter areas in the field of view. I see a question, or I see a request to spot any exoplanets. So the dealio there is exoplanets with this telescope. And we can't really like zoom in and look at one because exoplanets are going to be light years away. Exoplanets are planets orbiting other stars. So planets orbiting any other stars, mostly in our galaxy. It's very difficult to detect exoplanets in other galaxies. Our programming here, we can't quite detect an exoplanet for you, but normally how people will do it is they'll use something like the transit method, where we'll be analyzing a star and looking at how bright a star is and looking at like the luminosity. So there's this kind of line of the brightness of the star, luminosity of the star, and occasionally what we'll see, or what astronomers will see, is like a dip in the luminosity, and then it'll go back to normal. And the dip in luminosity is something, or some planet, some rocky body, some gaseous body passing in front of that star. So that luminosity is going to dip. And that's actually how we can figure out a bunch of stuff from the exoplanet. We can figure out how quickly it's orbiting about the star, the diameter of the exoplanet. We can learn all about that system, that exoplanetary system. I see a request from Zach to see the moon. That guy looks great. However, he is a new moon right now, so we can't grab him tonight, but maybe next time we might be able to grab him. I see a secret request for IC 1101. So I think this guy was it like I think it was a giant galaxy that we were super excited to look at, that us educators were excited to look at the other night. Are we able to grab it? Yes, we are. Perfect. And the reason why this is cool is this galaxy is 1 billion light years away. 1 billion, which is like, I've been saying like, tens of millions of light years, and like, blah, 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 million miles away. And it's like, I'm just throwing out these big words, but like, what do they mean? And how I like to like put things into perspective. Right in the center there, if we zoom in, we might be able to, maybe we could up the exposure a little bit, and then I'll explain a thing real quick. So how I like to think about like how big things are, or like how big numbers really are, is if you were to count to like 1 million, like 1,000, 2, 1,000, or like 1 million seconds, that would take you about 11 days. like 11 days straight. And if you were to count to a billion, that would take you 32 years. Like no breaks or naps or anything. And kids all the time will be like, oh, well, I can do it right now. Look, 1, 2, 3, 4, 5. And it's like, no, 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 no. Like actual seconds, a billion seconds is 32 years. And if you were to count to a single trillion, a light year is 6 trillion miles. So if you were to count to a single trillion, 1/6 of a light year, it would take you 32,000 years. So a trillion is a big number. A light year is a very large distance. And this guy is a billion light years away. So right in the center there, are we able to zoom in like a little bit more? Yeah, it's a galaxy, a billion light years away. So it looks like a little elliptical galaxy, or probably a big elliptical galaxy. So no, not a ton of gas that's helping form little baby stars, but more so just a bunch of stars orbiting the galaxy center of mass. Thank you for the request, Sarah. So I see a question that says, have you guys found any new stars or supernovae? Now, new supernovae appear in other galaxies all the time. And there's actually one that appeared a couple weeks ago in the galaxy IC 3322. Are we able to jump over to that galaxy maybe? I don't know if we'll be able to see the supernova with this telescope, but normally supernovae in other galaxies. Yeah, so IC 3322, it's distant, so it's going to be a little faint, but I promise you, a supernova just went off in there. So it's a faint galaxy and the supernova's over. So that explosion definitely won't be visible, but it did happen. It's been a few weeks since the supernova went off, but yeah, so in IC 3322, a supernova went off. And what a supernova is it's a death of a supermassive star. So this really massive star, burns fuel for billions of years, and eventually it runs out of fuel. So it starts fusing the elements that it's already created. So all stars are doing is they're just these little element factories. Can we see 2 galaxies in this field of view? I think there's one off to the left too, right? Yeah, little dudes, and one just up above. Anyways, yeah, right in the center. That is, yeah, little dude, little tiny guy. Aw. The galaxy in the center is where the supernova just went off. Yeah, so supernovae, yeah, we can see 3 little galaxies in the field of view. Nice. Actually, I'm like seeing more and more as I keep looking, but I'm gonna stop pointing them out. The galaxies are gonna be little smudges. Yeah, that little guy, the one to the bottom, yeah. And then the stars are gonna be like bright pinpoints. But yeah, supernova is death of a supermassive star. Once that star can't fuse anything else, it throws a hissy fit and explodes. And if it's a supermassive star, it's going to be like a supermassive death. So it's going to be like a giant, really bright explosion, kind of spewing out all of the heavier metals that it created throughout its lifetime. Yeah, supernovae are neat little dudes. Neat big dudes. I call them all little because I think they're all so cute, but they're a lot bigger than I am. I see a question asking how many types of galaxies are there? So there's a phrase, it's like the Hubble tuning fork of galaxies or something like that. Looks like a tuning fork. If you like Google it, it'll come up and you'll know what I mean. But there's a bunch of different types of galaxies. We've been looking at spiral galaxies for the most part and elliptical galaxies. And there are like different types of spiral and elliptical galaxies, like barred spiral galaxies, different sizes and ages. And then there's also like irregular galaxies and galaxies that are colliding, like the antenna galaxy we saw a little bit ago. I'd say, oh man, how many types of galaxies? I couldn't tell you a number off the top of my head, but I'm thinking of like 10 types right now. There's the Hubble tuning fork of galaxies. There's like spiral like A and spiral B, like SA, SB, SC, something like that. And then there's like elliptical 0, elliptical 1, something like that. So there's a bunch of different types of galaxies, and what types just mean like how they look. So they can, you know, there's a bunch of different ways galaxies can look. I see a question. May is supposedly the best month to see Mercury. Is Mercury still up? So Mercury has set. Normally Mercury will set like just after the sun has set. So when we've been viewing at the Open Deck Observatory, actually like just like yesterday and 2 days ago, we've been able to grab it right as the sun is like still in the sky. And we were able to grab Mercury, but he's setting pretty early. But if we're able to see him on the western horizon, like just after sunset. When I've been viewing him, he's the sun's still kind of been in the sky. The sky's still been pretty bright. So Curtis Horn says, how about Caldwell 35 tonight? It's a galaxy cluster, so we can try it out. That cluster is also known as NGC 4889. So this is a supergiant elliptical cluster of a whole bunch of galaxies. So we're gonna see if we can grab some different galaxies in the same field of view here. So yeah, we're going to be taking a longer exposure. So this field of view, okay, 4889 is, okay, sorry. 4889, I'm reading behind the scenes comments, oh no. 4889 is one galaxy, or Caldwell 35 is one galaxy. So the one galaxy is the supergiant elliptical galaxy. Cool. Yeah. So we're able to see a couple elliptical galaxies in here. Wait, is that like that's like a lot of galaxies. That is a bunch of guys. Wow. Okay. Wow. So we can kind of see, yeah, we can zoom in here and see all of the different galaxies that we're looking at. So I love that. So yeah, we're zoomed in, all a bunch of those guys where that yellow dot site is. These are all the galaxies that we're looking at. So again, stars in this field of view, that is a lot. That's really cool. I like that a lot. Thank you for this request. You can see like the star, really bright star, has the little kind of twinkle coming off of it, and other stars are like the bright pinpoints, and like the fuzzier kind of look like yellow smudges. Those guys are galaxies. So yeah, and we can see a spiral to the upper left. So that kind of linear, more linear galaxy, that is a really neat view. Wow. So I think the brighter elliptical galaxy to the right is the center. So that is the Caldwell 35, or the NGC 4889. Wow. Yeah, so there's all of those little ellipticals kind of following around him. I like that. Sorry, I keep repeating myself. I've never seen like that many galaxies in one field of view. He's got a bunch of friends. They're having a party. They planned it. Plan it. Okay. I see a request for the Coma cluster. So I think Abell 1656 is a galaxy in another cluster of galaxies. So we can try to see if it's visible in here. Yeah, cool. So we're going to jump on over. Maybe we can see more spiral galaxies in a cluster. Elliptical galaxies are really neat too. They don't get enough love. People always mistake them for stars, but they're not. They're a lot more than stars. Yeah, cool. All right. So there's a bunch of, not exactly galaxy collisions happening here, but there's a lot of mutual gravitational forces going off in this area here. So In a couple seconds, we'll see how different these clusters look. Cool. Little guys. Oh, so it's the same cluster. Okay, I understand now. It's the same cluster. We're just, I think we just kind of moved a little bit, so we're able to see a little, some different galaxies. Cool. Okay. So I believe we have a request for the butterfly galaxies. So NGC 4567 and then NGC 4568. They should be near each other, next to each other. So they're the Siamese twins. So we're going to go ahead and, lessen our exposure a little bit. So since we're looking at a bunch of different galaxies in the same field of view, if we were to take like a 10-second exposure, we'd probably only get like maybe the two galaxies, the two brightest galaxies in this field of view. Since we upped to a 30-second exposure, we're able to see all the other little guys kind of surrounding them. So these galaxies, I actually don't think I've ever seen. Ooh, more. Oh, there's 3 in the field of view too. Oh, wow. Little guy. Oh, neat. So this is another example of a galaxy collision. It looks like the top galaxy there is kind of getting pulled down. The bottom of the top galaxy looks to be getting pulled down towards the galaxy kind of straight across on the bottom there. That is really neat. Yeah, so we can see these guys are more spirals. We can see the darker sort of areas where that star forming is happening, and the two cores of the galaxies as well. Yeah, hanging out in there. Oh, cool. I like that. So I see a request for Comet C, or C/2020 R4 Atlas. Now, I believe that we have the coordinates so that we can try to grab this guy. So with objects like comets, since they're not going to be like in the same place all the time, we have to type in like the exact coordinates for them. So the exact right ascension and declination, kind of like the latitude and the longitude in the sky. So we're swinging the telescope on over there. And comets, we may be able to see some fuzz of a trail, but it may just end up looking more like a star. But the coordinates that we're looking at right now, the hour angle and the degree that we're looking at right now, this is where that comet should be located. So I think a comet is kind of like dirty snowballs, because comets come from the outskirts of our solar system. They come from the Kuiper belt, and as they're orbiting about our sun, there's some closer approaches, and when they come closer to the sun, their ice ball bodies start evaporating, and we get this kind of trail coming through. Is it the guy in the center there? I think we might up the gain a little more. We're taking a longer exposure. So it looks like there's a little kind of smudge. It might be that guy. Yeah, maybe that guy in there. So I think it comments as dirty snowballs because it's mostly ice with like some dirt in there. Nice. Yeah. So yeah, I think that is the guy. So we can zoom in a little more. We can see the difference. Oh, cool. Yeah. Yeah, so we can see the difference between the stars in there. Those are like individual points. And the comet, we can see it's more of a fuzz. And then we can see that it's kind of going down in that direction. And its tail is kind of leaving that trail down there. So let's try. Okay, so I see another request for NGC 4676. And I think we might do like three more objects after this guy, 3 or 4 more objects after this guy. Yeah. So 40 NGC 4676, the mice galaxies. I don't think I've ever looked at these guys. But if there's more than one, I'm interested. We've been looking at a bunch of really cool galaxies tonight. I'm like stealing all of your guys' ideas because you guys are super smart. Okay, so we're zooming on over to the mice galaxies. We're going to be taking a 20-second exposure of this area of the sky. And oh, did we move? Did we move the telescope at all? Oh, it's those two guys in the center there. Okay, neat, neat, neat. So this may be another galaxy collision. I can't tell if coming down off the bottom galaxy, is that like a stream of stars or is it just like my eyeball? If we like move the screen around, or yeah, we're gonna be taking a longer exposure, so it may be easier to see. So it looks like it's galaxy collision. And I think that, yeah, cool, wow. That's neat, yeah, so I think the, yeah, that's really neat. So the galaxies are, the gravitational forces of these galaxies are interacting in such a way that the galaxy in the bottom, just all of those stars getting flung out behind him. Kind of looks like a galactic comet. That's cool. I like that guy. I saw a request to view the Christmas tree cluster. He is below Gemini right now, and he's below the trees up at our open deck observatory, so we're not able to grab that guy, but that is an open star cluster, and I believe we grabbed another open cluster in Auriga earlier. So I see a request for Markarian's chain. Cool. So I think we'll jump to Messier 84, which is one of the galaxies Markarian's chain. There's a lot of really neat galaxies coming up right now in the constellation Virgo, because Virgo is kind of where the Virgo supercluster is. And that's like the center of the giant cluster that our galaxy is a part of. So we have a bunch of really, really neat deep sky objects, really neat galaxies that are rising right now, like hundreds of different galaxies that are coming up. So we're taking a longer exposure of this guy right now. And yeah, so these guys are going to be some brighter galaxies. So we see 2 elliptical galaxies, those 2 little bright guys. If you squint, it kind of looks like a little face, kind of going like that. I don't know, it's just me. Looks like a little, like he's really tired. That's what that face, looks like a little space face. Anyways, there's the 2 elliptical galaxies. And then there's a spiral off on the bottom there. So we can see the core, and then we can see those darker cloudy areas in the bottom there. It looks like there's a bunch of ellipticals there in this field of view. I like Markarian's chain. All right, so I think I want to try, we can jump on over to M64, and then I want to try ending on M94. Because I don't think, I've probably seen him before, but I haven't, I can't recall. So M64 is the Black Eye Galaxy. This was I like looking at this object a lot through the plane wave telescopes because the area of sky, or just the shape of the galaxy and the color of the galaxy, the dust is so dark that it looks like it got socked in the face. So we see, yeah, nice. So we see, yeah, it looks like it got punched in the face. That's a really cool image. That's really neat. So yeah, there's the core of the galaxy, and then it kind of like even just the galaxy shape looks like an eyeball. And just beneath that core, it's that really, really, really dense gas. That what looks like a really dense cloud. And we can see the spiral arms of stars kind of coming out of that core there. So I want to see the Whale Galaxy too, though. Okay, let's do the Whale Galaxy. Let's do NGC 4631. This guy, I actually only recently saw like maybe like a month or two ago for the first time. And the Whale Galaxy is named as such because it looks like a space whale. It looks like a whale out in space. So kind of like it reminds me of the Cigar Galaxy, which we saw a little earlier, where there's the side of the galaxy. Instead of looking face on, we're looking edge on. But the gas in the galaxy and how the galaxy is shaped in such a way to where it looks like a really long blue whale kind of going through space. There's also, it looks like a satellite galaxy just beneath it, or it may be a galaxy behind it. But here, it reminds me of the cigar just because it's like the gas and it's like sideways, but this guy looks not as it doesn't seem to be as bright as the Cigar Galaxy, because these all these star forming regions are like really dense right in front of the galaxy's core there. So those brighter dots that we see in the Whale Galaxy, those are actually like X-ray sources. So those are really energetic points, or like super hot energetic points in the galaxy. So we see similar points. Actually, I think we took a picture of the Whirlpool Galaxy earlier. We see similar like really bright points in the Whirlpool. So yeah, zooming in, we can kind of see there's like the bright star or the darker star forming regions, and then a bunch of really bright points in the galaxy. So those are those areas. If we were to like look at this galaxy with like the Chandra X-ray Observatory, they'd like be they're very powerful, very bright X-ray sources. So really energetic, hot particle sources. All right. I see a question for how many telescopes does Lowell have? For viewing, we currently have there's a total of 6 at the Open Deck Observatory, but right now we're viewing through 5 of them. There's 5. There's the Dyer telescope. There's the Clark telescope. We also have our solar telescope. I hope I'm not forgetting one. So I think we have 8 different telescopes that the public can look through. We have our research sites as well, which are not open to the public. And those research sites. Oh, we also have a bunch of portables. Yeah, so that's like, what, we got like 3? More than that? 8, maybe around 10, give or take a few. 10, give or take a few telescopes that are available for the public. But yeah, we have 2 active research sites that are not open to the public. One of them has 4 telescopes, and the other one is one really big telescope, a 4.3 meter reflecting telescope. So I like that guy. That's the Lowell Discovery Telescope. He's in Happy Jack, Arizona. All right. Let's finish off on an earlier request for the birthday girl, which was M94. So M94 is also known as the Croc's Eye Galaxy. So this guy is about 16 million light years away. So we're taking a 21-second exposure. We're still on the Whale Galaxy now. And this is interesting because this galaxy is like half referred to as a spiral and also half referred to as a barred spiral galaxy. So just normal spiral spinning around. And then I think maybe lessen the gain a little bit. And then, yeah, because there's a normal spiral with the ring spinning, arms spinning around. And then there's a spiral with the core and then the lines coming out. And the arms coming out of the bars in the spiral. So this guy, it's the bars or the oval of where the arms are coming out is like more barred than oval, than the perfect spiral. So yeah, if we're able to, we're going to lessen the exposure because the core of that galaxy is really bright. And then I think we might be able to see a little more detail, maybe if we zoom in a little bit. But yeah, we can definitely see the spiral arms kind of coming out there. Cool. Yeah, so how odd. Yeah, normally we have to take longer exposures of galaxies, but this guy's just really bright in the core, so we're lessening the exposure pretty low. Maybe if we dropped the gain again. I want to see the center. I want to see the center. So yeah, now we're taking an 8-second exposure because I want to see what the fuss is all about. Is it a barred galaxy or is it a spiral galaxy? Ah, man, just not our day. Well, all right. So, I see, I didn't say the cross-eye galaxy. I said the croc's eye, like a crocodile eye galaxy. Okay, Google says it's a spiral galaxy, but I was reading some stuff earlier about it and it said it was a spiral, but the spiral in the center is just really smushed. How do I know so much? I love Lowell. I learn for a living and I dig it. All right. Well, with that, we've been hanging out for about 45 minutes now. So I think we're going to go ahead and call it. But before I go, I would like to mention we do these interactive stargazings every Tuesday. So if you have some other things that you want to request, if you're too scared to request them tonight, request them next week and we'll try to get them. Also, after this live stream, we will be going live on Twitch with another one of our educators, and we'll be hanging out, vibing, playing games, talking about space. So if you have extra questions that you want answered, feel free to go bother our friend Jacob over on our Twitch channel. So with that, thank you guys again so much for hanging out with me. Thank you for asking really good questions, and I loved looking at galaxies with you guys. And we will hopefully see you guys next week. So thanks again. Have a good one.